Hello students, welcome back to my channel. In this video, we will study about system, assembly and ensemble. Okay, these are the topics that comes under statistical thermodynamic. Okay, now we will first study what is system. We already seen in the introduction part of statistical thermodynamic, every individual particle that is present in a container. For example, if you consider this is a container, okay, or a beaker or whatever, it is closed, okay, and imagine inside this you have a gas, okay, say you have nitrogen gas, okay, inside this you have a nitrogen gas, okay, and these are the nitrogen molecule, okay, these dots are representing what? N2 molecule. And we said that in the introduction part, in the statistical thermodynamic, we are studying the properties of individual particle, right? We are studying the properties. So what are the properties? Properties are nothing but a pressure, temperature, volume, energy, entropy. Okay, these are all the properties. Okay, now in the statistical thermodynamic, we are studying the property of the individual system. While in the classical thermodynamic, what we are doing? We are studying this entire container as a one and determining its property, right? That is what classical thermodynamic is. Well, now according to the definition of the system, so what is the definition of system? The system is nothing but it is the one which is under study, and that is separated from the surrounding by imaginary or real boundary. This is what the classic definition of the system, right? It is nothing but it is the one which is under study. Okay, so one which is under study is called a system. Okay, now I said that in the statistical thermodynamic we are studying individual particle. Okay, so this individual particle itself called as system in the statistical thermodynamic. Okay, the individual particle are called as what? System, because according to the definition of the system, the one which is under the study is called as the system. Okay, now in the statistical thermodynamic we are studying individual particle. That means these particles are under study. That is why each particle that is present in the container is called as system according to what? Statistical thermodynamic. While according to the classical thermodynamic, what is system? This entire container is there, no? This entire container is under observation or it is under study. That is why this entire container is called a system according to what? Classical thermodynamic. But according to statistical thermodynamic, each individual particle that is present in a container is called as what? System. Okay, hope it is clear. We will move forward to the assembly. Okay, now we will see what is assembly. Okay, assembly is nothing but it is a collection of system. System means what? It is nothing but a individual particle, that is called as what? System. Okay, whenever I mean particle, you should understand that it is a system. Okay, or whenever I say system, you should understand that it is nothing but individual particle. Okay, but now assembly means what? It is nothing but a collection of the particle or collection of system. Now if you imagine, this is one nitrogen molecule. Okay, these dots are representing what? Nitrogen molecule. Okay, I written one nitrogen molecule. Okay, now this is become what? System. Now I have collection of system or collection of particle. And now what we call this? We call it as assembly. Okay, assembly means what? It is nothing but a collection of particle or system according to what? Statistical thermodynamic. Okay, well, next we will look into very important ensemble. Okay, we will understand what is ensemble. Before understanding ensemble, let us write the definition for the ensemble. Okay, it is the collection. Okay, it is the collection of very large number of assembly which are independent of each other, comma, but which have been made macroscopically as identical as possible. Okay, this is the proper definition of ensemble. So let us read what is ensemble. It is a collection of very large number of assemblies which are independent of each other but which have been made macroscopically as identical as possible. Okay, now we will understand what is the meaning of this. Okay, now to explain this ensemble, what I do is I take one example. Okay, I take an example of simple ABC school. Okay, let me call some school named as ABC. Okay, in this school there are 1 to 10 classes. Okay, that means first standard, second standard till 10th standard. Okay, so that school is called as what? ABC school. Okay, now we know that in the school there will be an assembly on every Monday, right? So during assembly, how will be the student will stand? The first year student will stand like this, right? In the row, correct? These are all what? First year student or first standard student. Similarly, second standard student will stand in another row, correct? Okay, there may be many students. Okay. Similarly, third standard student will also stand in a row. They don't mix up, right? The third year student will stand in a row, single row. And similarly, the 4th, 5th, 6th, 7th, 8th, 9th and finally the 10th standard student also stand in a row. Correct. Now what do we call this individual student? Individual student is called as what? System. Okay. Individual student or according to the definition, particle. Okay. Now here it is student. Okay. These dots are representing what? Student. Now individual student is referred to as system. Now you can see that there are many students or collection of the system, right? So this row is called as what? Assembly. Or this row is also called as assembly. This is another assembly, this is another assembly and this is another assembly. So you can see there are many assemblies, right? So there are many assemblies, 10 assemblies are there here, right? Well, now read the definition. It is a collection of very large assembly. Okay, it is a collection of very large assembly. Okay, we have seen there are 10 assemblies in this case. Okay, now just imagine you consider this student, first standard student. This is a second standard student. Okay, I just mark them. Okay, simple for understanding. Okay? Now this student is from the first standard. This student is from the second standard student. Okay, well now these students are not related, correct? These students are not related or they are independent of each other. Why? Because we know that this student is from the first standard, this is from the second standard. That means they are not same. Okay, they do not belong to the same class. They are different. They are independent. They are present in a different classrooms, right? So that is why you can see here which are independent of each other. Okay. Similarly, if you consider this student and this student, they are not dependent, right? Because they are belong to the different assemblies. We can see that this is belong to the first standard, this is belong to the second standard. Means they are not connected. Okay. They are totally independent of one another. Okay, that is what the second statement is telling. Okay, it is a collection of very large number of assembly, we just now saw, and which are independent of each other. Correct? So each assemblies are not related. Okay, they are totally different from one another. Okay, because they are belong to the different classrooms, right? So they are independent. Well, now next statement states what? Which have been made macroscopically as identical as possible. What is the meaning? Now, what do we call this entire assembly? Now, let me show you properly. Now, if I consider entire assembly as a one or bulk, if I consider this in the bulk, what do we call them? We call them as they are the student of ABC school, right? We call them as what? They are the students. Okay, this is also student, this is also student. Okay, they are similar. No, the first standard student only, the 10th standard student only, right? They are all students. That means whenever you see in the bulk or whenever you see in the macroscopic scale, okay, macroscopic means bulk, larger quantity. If you take it in the larger quantity, they are identical, right? They are nothing but students only. Whether they are from first year or 10th standard, they are students only. That means if you consider in the macroscopic or in the bulk, they are same. Okay, that means they are the students of ABC school. That means if the outsider comes, okay, for example, if the outsider come to the assembly, they do not know that this student is from the first standard, this student is from 10th standard. They will be not knowing, right? They simply tell that they are the student of ABC school, right? So macroscopically, if you consider, they are identical. That is, they are the student of ABC school. Okay, just like that, if you consider this assemblies as bulk, okay, or if you consider in the macroscopic scale, they look like identical. Okay, they will be identical as possible. Okay, this is how the definition is. But what is ensemble? It is nothing but it is a collection of very large number of assembly which are independent of each other. Means each assembly is independent of one another. But if you see macroscopically, they are same. They are identical to one another. Okay, this is the definition. Hope it is clear. Now we will move forward to the classification of ensemble. Okay. Classification of ensemble. Okay, there are mainly four types of ensemble. We have first one, that is macro canonical ensemble. Okay, this is macro canonical ensemble. The next one is a canonical ensemble. The third one is grand canonical ensemble, and the last one is a uniform ensemble. Okay, these are the four different types of ensemble. So what is the first one? Macro canonical ensemble, canonical ensemble, grand canonical ensemble, and the uniform ensemble. Okay, let me call it as 1, 2, 3 and 4. Okay, I write 1. Okay, that means I am explaining about the macro canonical ensemble. Okay, I am not writing macro canonical ensemble again. Okay, I am writing 1. Okay, now what is macro canonical ensemble? Macro canonical ensemble is nothing but it is made up of, let me write the definition first. It is made up of, okay, it is made up of large number of individual assemblies having same energy, same volume and same n. N is what? Number of particle or number of system. Okay, the particle is nothing but a system according to statistical thermodynamics, right? So, well, and we have definition. These individual assemblies, these individual assemblies are separated by rigid and well insulated wall. That means no energy, volume and n can transfer. Okay, this is the proper definition of the macrocanonical ensemble. Okay, what is the definition? It is made up of large number of assemblies having same energy, same volume, same number of particles. Okay, and these assemblies are separated by what? Rigid and insulated wall. Okay, that means there will be no exchange of energy, volume or number of particles with the other assembly. Okay, let me write the representation so you can understand it much better. The representation is like this. Okay, these are representing, these boxes inside is representing assemblies. Okay, these are all assemblies having what? Same energy, same volume, same number of particles. Okay, E, B, N. E, B, N. Not only 4, okay, there will be many assemblies, but I written only 4, okay. And what's the next statement? These assemblies are separated from the other assembly by what? Insulated wall. Insulated and rigid wall, right? So, I representing these by, some lines. Okay, this is insulated wall, insulated and rigid wall. Okay, what is this? This is nothing but assemblies. Okay, this is representing what? Assembly. Okay, so this entire thing is called as what? Macrocanonical ensemble. Okay, so we can see that it is a collection of very large number of assemblies having same energy, same volume, same number of particles, and they are separated by what? These rigid walls. You can see rigid walls. And since we know that it is a rigid wall as well as insulating wall, there will be no exchange of energy, or there will be no exchange of volume, or there will be no exchange of number of particles. Okay, so this is similar to, that means this macrocanonical is similar to isolated system in a classical thermodynamic. According to the classical thermodynamic, we have 3 different type of system, right? One is isolated system, closed system, another one is a open system, right? We know that in case of isolated system, there will be no exchange of heat or matter with the surrounding, right? So here also you can see there will be no exchange of anything with the other assembly, right? That is why it is comparable, or it is similar to the isolated system of what? Of classical thermodynamic. Okay, this is the first one. The second one is what? Our canonical ensemble. Okay, let me represent the canonical ensemble first. Later that I will tell you the definition. Okay, here there will be no rigid or insulated wall. Okay, there will be no rigid or insulated wall. Okay, there simply closed kind of simple wall is there between the assemblies. Okay, T means temperature, V means volume, and N, it is the number of particles. Okay, now how you will be writing the definition? The definition is just like this. Okay, whatever you have written now here, it is made up of large number of individual assembly having same what? Here it is what? Temperature, volume and number of particles. Okay, it is made up of very large number of assemblies having same temperature, same volume and same number of particles. That is what the definition of canonical ensemble. Okay, now here you can see that, as I already said, that it is not a rigid wall, correct? As a result, what may happen is that the temperature may exchange with the other assemblies. Okay, the temperature can be exchanged with what? With other assemblies. Okay, the temperature can be exchanged with the other assemblies. Therefore, in this type of ensemble, there will be equilibrium. Okay, in this type of ensemble, we can see that there is a thermal equilibrium. Okay, because the temperature can be exchanged, no? But what about n cannot be exchanged. N means what? Number of particles. They cannot be exchanged with the other assembly because they are closed, right? Even though it is not a rigid, the number of particle cannot be exchanged. Okay, it will remain in this assembly only. Okay, so this is similar to which type of system? It is similar to which type of system in classical thermodynamic? It is similar to closed system of classical thermodynamic. Okay, classical thermodynamic, because even in the closed system we see that there is an exchange of temperature with the surrounding, but the matter cannot be exchanged, right? That is what a closed system according to the classical thermodynamics. So here also you can see the temperature can be exchanged, hence it can be comparable, or it is similar to the closed system of the classical thermodynamic. Okay, now we will see the third one. Third one is what? Grand canonical, right? Grand canonical ensemble. Let me represent first the representation. By writing the representation, you will get to know what is it, what is the definition. Okay, here it is TV mu. Okay, in all the assembly you need to write the same. TV mu. T means what? Temperature. Mu means what? It is a chemical potential. Okay, V means a volume. Okay, now what is the definition you can write? The definition is that it is made up of very large number of assemblies having same temperature, same volume, same chemical potential. Okay, mu means what? Chemical potential. Okay, so what's the definition? It is made up of very large number of assembly having same temperature, same volume, same chemical potential. But what about the wall? It is not rigid, it is not even closed, and you can see there is a gap. That means it is a perforated wall, or it is a permeable wall. Okay, permeable wall. Okay, these are representing what? Permeable wall or perforated wall. We know that permeable means what? It has the ability to allow, right? Allow to pass into the other assemblies. That means here temperature can be exchanged with the other assembly, as well as the number of particle, that is n. N means what? Number of particle or system can be exchanged with the other assembly. So in this type of ensemble, what we saw, there is a exchange of temperature as well as there is a exchange of number of particle with the other assembly. Hence it is similar to what? Open system. It is similar to what? Open system of classical thermodynamic. We know that in classical thermodynamic we have open system, and in the open system both the temperature as well as the matter is exchanged with the surrounding. Just like that, here also the temperature as well as number of particle can be exchanged because the walls are permeable or perforated, so both can be exchanged with the other assembly. Okay, so it is similar to open system. Now fourth one, that is uniform ensemble, right? Uniform ensemble. Okay, uniform ensemble means the density. Okay, in uniform ensemble, density in the phase space remain constant. Okay, phase space remain constant. Okay, that's it. Uniform ensemble, the density in the phase space. We have made the video on phase space. Okay, if you haven't watched the video, please go and watch, because if you do not know what is phase space, maybe you are not understanding this. Okay, so what is uniform ensemble? It is, or in the uniform ensemble, the density in the phase space remain constant. Okay, well, there is some little equation here. Limit delta V tend to 0, 1 by delta V is equal to limit n tend to infinity, delta n by n is constant. Okay, please copy this. Okay, what is delta n? Delta n is the number of system or number of particle. Okay, whenever I mean system, you should understand that it is nothing but a particle. Okay, so delta n means what? It is a number of particle or number of system in an element of volume delta V. Okay, delta V is the volume. So what is delta n? Delta n is the number of particle or system in an element of volume delta V. N denotes, where is n? Here. Okay, here it is delta. Okay, n denote the total number. N denote the total number of particle or total number of system in the ensemble. Okay, n denotes what? Total number of the particle or total number of the system in the ensemble. Okay, these are the 4 different type of ensemble. Hope it is clear. If you have doubt, you can ask. Okay, thank you for watching.